Hello, good morning students. So previous class we talked about biomass and how energy can be derived out of different type of biomass. We classified biomass into different groups and after that we found how different biomass can be used to generate energy and different methods we classified. Okay, so the first method, conversion method was thermal method, in which we studied combustion as a method. Okay, in combustion, we simply heat up the material, the biomass, with the presence of sufficient amount of oxygen. So we got thermal energy. So next one was chemical method. Chemically also biomass can be converted into useful form of energy. So the first one was pyrolysis that we studied, in which the material is roasted or heated up to high temperature in the absence of oxygen. So certain gases were formed and certain solid material were formed and certain liquid material were also formed. And we studied two types of method. One was pyrolysis and second one was gasification. Okay, in gasification, temperature is much higher than that of pyrolysis, and in gasification you can use any type of material. Even plastic materials were used, whereas in pyrolysis we used mainly wood-like material or agro-based material. Whereas in gasification you can use many materials like plastics and other artificial materials too were decomposed, and on decomposition we get the very useful gases like syngas or synthetic gas, which is a gaseous fuel. Okay, and thirdly, today we will see two biochemical methods, how certain biomass can be converted into useful form of energy or useful material from which energy can be derived. Okay, and biochemically we will convert certain biomass material into useful forms. Okay, the first one is called fermentation. This is what we want to discuss today. How fermentation method is a process, is a biological or biochemical process by which certain biomass you can decompose, and the decomposition give you some products. So they are of very great application. And finally, we have the last method, biochemical method, that is called anaerobic digestion. Anaerobic digestion. We will surely see what is anaerobic digestion means, its definition, then how anaerobic digestion can be used to produce useful form of energy. Anyway, in biochemical method, we will not be directly producing energy. Instead, some other raw material, you can see more refined or more value-added products. Okay, fermentation process will not directly give you any energy. Instead, the fermentation process will give you some value-added products. So, from that products, energy can be much easily made out, much easily obtained. Okay, hope that idea is clear. Similarly, in anaerobic digestion also, certain raw materials after certain biochemical processes will give you some value-added products from which energy can be very quickly, very rapidly made out. Anyway, we will see all this today. So we will begin with fermentation. How energy or energy deriving products can be made out of fermentation. So first, let us see what is the definition of fermentation. Here is a simple definition of fermentation. Fermentation is a chemical process by which organic molecules such as that of glucose are decomposed down into smaller molecules in the absence of oxygen under the action of yeast or some other microorganisms. So the definition is simple. Okay, what is happening is we have certain materials which contain glucose. This material can be that of say some cane juice. Cane, cane means karimbu. In Malayalam, it is called karimbu. So that contains a lot of glucose. So if you add into that yeast is a bakery material. Basically, it is a fungus. Yeast is a fungus, a microorganism. Okay, there are large species of yeast. Around more than 1,000 types of yeasts are there. Okay, anyway, usually mankind you make use of very few number of yeast in the food applications. Okay, for example, in bread production, bakery production, or in wine production, liquor production, yeast is made use. Different types of yeasts are used. So if you put a sufficient amount of yeast, is an organic microorganism. You can say a single cell fungus. It's a type of fungus, single cell fungus. If you put such an organism in glucose solutions, the solution will get decomposed and you get some fuels. For example, alcohol. Understand? So let us see how that is produced. So I hope you got an idea about the fermentation. Okay. So in the fermentation, we have some sugar-based solution in which some microorganism is put or mixed up. Then microorganism catalyzes, initiates certain chemical reaction by which the glucose decomposes and we get some useful fuel. Okay. So that is what is meant by value added production, or from which you can more readily generate energy. Okay, so for centuries people have been using yeast and such other microorganisms to ferment the sugar of various foods. Understand? So you can add this yeast into say grape juice, apple juice, or many juice, into which you can add yeast and you will get ethanol. Ethanol is a good fuel, a high calorific fuel, ethanol or ethyl alcohol. Okay, and producing fuel from biomass by fermentation is just an extension of this product. Or a wider range of plant materials from sugar cane to wood fiber can be used. So that is an interesting idea. Okay, for thousands of years, yeast has been there and people have been deriving alcohol out of these food products. But more recently, many other agro-based or biomaterials like other parts of the plants or wood fiber, cellulose-based materials, etc. can be decomposed and you can produce alcohol. So it is more profitable. Okay, getting alcohol from fruit juice is not so easy and you cannot use it as fuel because the amount available is very less. The quantity of fuel available is very less. So it is not a cost effective. But you can, if you can derive alcohol or extract alcohol from wood material, other wood materials, so that is more cost effective. Okay, so people have found such yeast or you can say biotechnologically derived microorganisms that can be used to get alcohol. So once you have the decomposition, once the glucose or the base material is decomposed, what is done is we conduct what is called a fractional distillation. So in fractional distillation process is very simple. You just heat up the material. So what happens? Different materials undergo evaporation. They convert into gas. So that gas or vapor you can collect. Understand? So those vapor can be separately collected. So that is called a fractional distillation. Okay, so this can be done. So in ethanol production, for example, it's a typical production of alcohol. You have a corn. Okay, corn, it can be cane juice or any other wheat or paddy. First it is grounded well, thoroughly grounded well, made in the form of a paste. Okay, and mixed sufficiently with water, and a process is taking place called saccharification. In saccharification, what is done is sugar part is separated. There is a sugar part that is separated. Then the remaining solution is subjected to fermentation. So the solution left after the separation of sugar is subjected to fermentation by adding yeast. Okay, so at that time, this solution gets separated into different components. Okay, so one component will be alcohol, and that is a very good fuel. Very good fuel. You can mix it with petrol, gasoline, or you can mix with other diesel, and it can be used in transportation in vehicles and other automobile machines. Understand? So it has been in practice in many countries like Cuba, Brazil, even in India to some extent, and in the United States. So this has been in practice, mixing of suitable amount of alcohol with other petrol-like material and using in automobiles. So this is how the yeast looks like. As I told you, it is a single cell fungus, and you can get dry yeast as well as wet yeast. It has different applications like bakery products or in brewing industry. Many large varieties of yeasts are available and biotechnologically made. By artificial method, you can make yeast and it can be used for producing various industrial products. And these are the alcohol derived alcohol. It is used for fuel purposes, in machines and all. Okay, and recently scientists have substituted a genetically engineered bacteria. Okay, this is a type of yeast, you can say a catalytical agent in place of yeast in the process. So what happens? The fermentation process becomes faster and the production becomes very fast. The processes highly increase the efficiency and speed by which the waste paper and other forms of wood fiber can be fermented into ethanol. Okay, so this is more attractive business because waste paper, whatever wood waste is left behind, you can make it into suitable solution form and add those genetically engineered bacterium, and it will decompose into useful biofuels. Okay, ethanol is one such fuel which find application in energy production. Okay, ethanol is then you can mix the ethanol with diesel to produce diesel. This is diesel. Okay, you can mix with diesel and that is used by trucks and buses in Australia. So it's a very interesting knowledge. Okay, and in many countries it has been adopted and they are mixing in appropriate ratio, and this way you can save money, which is the money consumed in purchasing petroleum products that can be saved. Okay, so and that is all about the fermentation, and it has been picking up in India too, business and industry, by which you can have a gradual switch over from the petroleum based energy needs to biofuel based energy paradigm. Okay, so it is gradually taking up. There are various challenges still. Hopefully, in the very coming few years, we will switch over into bio-based fuels. Okay. So anaerobic digestion is another method. This again is a biochemical method in which certain biomaterials are decomposed, and you will get some gas products. Okay, so these gaseous materials are fuel. We call it biogas. The gas derived from biomaterials is called biogas. Okay, so biogas make use anaerobic digestion method. So let's see what is anaerobic digestion. It's a definition go like this. Anaerobic digestion is a biochemical process in which microorganisms like bacteria break down biodegradable material in the absence of oxygen. So it is a process happening in the absence of oxygen. Again, certain microorganisms, they are bacteria basically, they decompose certain biodegradable material. Namely, you can say cow dung or animal dung or even human excreta. You can subject to decomposition. You have a tank in which you mix up all these with sufficient amount of water, and you add up this anaerobic bacteria in it. Anaerobic means any bacteria which live without or which reacts or initiate reaction in the absence of oxygen. So what happens? So the material start producing a gas. That gas is called biogas. You can suitably fill that biogas in cylinders, or you can directly use that biogas as a fuel, either in kitchen or in industry. There are various applications. Okay, so the base process is certain action of bacteria, anaerobic bacteria. On the action of anaerobic bacteria, biodegradable materials get decomposed, and it gives you certain gaseous products. Carbon dioxide is a product, methane is a product, hydrogen sulfide is a product, nitrogen is a product, hydrogen is a product. So these are all the byproducts plus some solid or semi-solid material. Anyway, we are focused or interested in the gas part, the gas products. Okay, so one of the byproducts of this anaerobic digestion is biogas, which is used to generate either electricity or heat, or can be processed into renewable natural gas and transportation fuel. So this is another application. Biogas you can suitably collect, and with suitable chemical reaction you can convert into other useful forms. Either you can use biogas as itself, or you can convert into other useful products, chemical products. Understand? So this is a big industry in many countries, including India. Many firms working, and even we have domestic units. You must have seen many homes. They use it as a biogas plant in which cow dung or any other animal dung, animal excreta is filled, and certain amount of anaerobic bacteria is mixed up, and they get enough amount of gas for their domestic applications. Okay, so here is some more detail about what is an anaerobic bacteria. Okay, anaerobic bacteria that do not need any oxygen to live. Okay, these are all anaerobic bacteria. There are more than 10,000 varieties of anaerobic bacteria. You can Google and you will get many brilliant photographs of anaerobic bacteria. Certain bacteria are very useful for human beings. Certain bacteria are very dangerous for the human body. Okay, so there are many bacteria within the human body. Okay, you see here in humans, these bacteria generally within the gastrointestinal tract. Okay, so that means in the intestine, you have a long gastrointestinal tract, you know. Okay, where they can live, they help for digestion, healthy digestion. This is required. That is the very purpose of when you take curd with you, or little amount of any such soaring thing. Okay, it may be wine. So they all help for digestion because they contain these certain bacteria which are very helpful for digestion. And in addition to that, it is containing soil, water, and any other food and any animals. Okay, it is a small list of examples given: actinomyces, bacteroids, okay, Clostridium, Fusobacterium, and Streptococcus. Okay, Porphyromonas. These are certain typical anaerobic bacteria. Okay, you can see brilliant photographs of anaerobic bacteria here. Okay, these are all bacteria. Some are enemies, some are friends of human beings. Okay, some are very useful, some are dangerous for human beings. Okay, so such bacteria are put in this biomass and they undergo decomposition. Okay, for example, the biogas plant, you know it, in which cow dung is mixed with many other animal excreta, and in which this kind of anaerobic bacteria are put in suitable amount, and they undergo reaction and the gases come up. Okay, this gas is collected and this gas can be suitably used. Okay, so biomass digestion works by utilizing anaerobic bacteria. These microorganisms usually live at the bottom of swamps or in other places where there is no air, consuming dead organic matter to produce methane and nitrogen. Okay, so the major byproduct of this kind of biogas plant is methane, and what actually is burning is the methane gas or hydrogen gas. Understand? In addition to methane, there will be hydrogen sulfide and carbon dioxide too. Okay. So by filling organic matter such as animal dung or human sewage into special tanks called digesters and adding anaerobic bacteria, we can get the combustible gases, okay, like methane. So this is what is happening. This is the exact chemistry of biogas plants. The process is very efficient means for extracting usable energy from such biomass. So there are industrial level biogas plants and there are domestic level waste biogas plants. Both are there. And in addition to this, you can also get biogas from landfill sites. In landfill site, what is usually done is, we will take a huge pits, okay, excavated huge pits in which waste, especially bio waste, expelled from major cities, metropolitan cities, will be filled. Okay, so keep in mind here no plastic is needed, only bio waste. Okay, that is why we usually nowadays we separate, okay, segregate the waste, bio waste, plastic waste, glass waste, like that. Okay, radioactive waste. So that is very important. So then only it can be harmlessly separated and utilized, recycled. If you mix up them together, it is a great danger for the human being. Understand? So here bio-waste is separated and put in huge pits. Okay, it will be very deep, meters and meters deep, to tens of hundreds of meters deep, and filled and kept there for few years. Then what happens? Automatically the anaerobic bacteria start working and they produce gas, methane gas, and over which suitable coverage is given. Suitable cover is given, maybe polythene based or plastic based or asbestos based, and long pipes are erected inside. Long pipes. These pipes are perforated. Perforated means full of holes. So what happens? Through these perforated pipes, methane gas enter and these gas get collected. So that can be used to operate a power turbine. Okay, gas turbine can be operated. So you see, from the waste you can generate electricity. Very beautiful idea. So there are such a huge pits in many in the vicinity of metropolitan cities, and waste can be suitably converted into energy. and the remaining part can be again recycled back to fertilizer, and that can be supplied to agricultural farms, agricultural applications. Understand? So, large quantity of household biomass waste, such as kitchen waste, garden pruning, and they can be dumped at the sites by taking huge hits. Okay. So, over a period of several decades, anaerobic bacteria at the bottom of the site could steadily decompose the organic matter and emit methane. Okay, it's a healthy process by which we can avoid environmental pollution, soil pollution. The proper degeneration or decomposition takes place, and this can be again reused for various applications. And energy is also obtained as a byproduct. So the gas can be extracted and used by capping a landfill site with a thick layer of clay or other non-corrosive material, and then inserting perforated pipes that would collect the gas and bring it to surface. So this gas is used for energy production. Okay, so this is another area where this anaerobic digestion can be used. First application we have seen in biogas plants, and this is another area, landfill sites. Okay, in landfill sites also sufficient amount of anaerobic bacteria can be deposited or mixed up with this waste, bio waste, and they start generating what is called gas, especially methane gas. Okay, and methane gas pipe application. And this gas can either you can use it for energy power production, or in many areas this gas is used for brick making. Okay, you know, in brick making, large quantity of heat energy required for roasting the bricks, baking the bricks, you know, baking, where also such gas is used. Okay, so there are many such plants even in India. Okay, now comes a very important part about biofuels. So there are certain fuels which are obtained from biomass. We have other fuels like petrol, diesel, kerosene, okay, gasoline. They are based on petroleum, okay. But these fuels are based upon biomaterial or biomass. Okay, the first one, important characteristics of biofuel is that they are renewable. Means you can repeatedly produce it. They never get finished like petroleum products. Petroleum products once finished. You cannot reproduce it. But these are repeatedly you can generate it. For example, alcohol that can be generated from sugarcane, and you can every year you can cultivate the sugarcane and you can produce alcohol. No problem. Okay, so this way you can cut short or cut down substantially the environmental pollution. Okay, so and this kind of fuels are widely used in transport sector in many countries, gradually replacing or gradually getting finding as a substitute for petrol and diesel. And two types of biofuels are essentially there. One is ethanol based biofuel. Second one is biodiesel. Okay, so bioethanol is essentially made up of biomaterials and by the process called fermentation. Whereas biodiesel, this is essentially made out of oils. Okay, you know, there are various agro-based oils. Coconut oil is a oil which you get from biomaterials, and palm kernel oil is there. Okay, soybean oil is there, sunflower oil, corn oil, canola oil. There are various types of oils. You know, these oils can be intelligently used to produce diesel. So they are called biodiesel. Okay, so let's see how they are produced. So biomass can be converted into transportation fuels such as ethanol, methanol, and biodiesel, or you can use it as an additive. Additive means you can add in small quantity to diesel and petrol. Okay, small quantity. Either you can use pure ethanol, or you can add this ethanol into petrol, and you can make combustion. Certain combinations. Okay. For example, ethanol, it is most widely used biofuel. It is made by fermenting biomass, which was cellulosic ethanol, means from wood products, okay, or farm products. Either wood can be pasted into, certain paste can be made by grinding it, and you activate with the yeast, okay, fermentation, which results in the production of certain alcohol. Okay, wood-based alcohol you can make. They are not drinkable, keep in mind, very dangerous. But those alcohol can be used as a fuel. Okay, ethanol. And then methanol. How methanol you get? By either by pyrolysis or by gasification. Methanol is also dangerous. You must have heard about many tragedies, okay, called a huge tragedy, or by taking toddy and all. Okay, these are all happening by people mistakenly taking methanol or this kind of ethanol for liquor purposes. So that lead to casualties. Okay, so it's very dangerous for human body, and it leads to death. So these are only useful for fuel purposes, not for edible or drinkable purposes. So methanol is also there. We have seen how methanol is made, how using gasification process or with pyrolysis process, how methanol is made, we have seen. And another important one is biodiesel, and it is made from oils and certain fats found in microalgae and other plants. Okay, there are various things like this. You can see palm kernel oil. This is what is palm kernel. Okay, palm. Certain seeds produced in Malaysia, like countries, and this is the raw palm oil. Once you get a juice from it, and when you refine it, you get palm oil. So this is the palm oil. Okay, this is a raw form. After getting extraction mills, it looks like this. Once you purify it, you get palm oil. And this is what is called jatropha oil. This is also a biodiesel. It is obtained from jatropha trees. Okay. This is a raw jatropha trees seed, and this is a dried jatropha tree. And this is jatropha kernel inside it. From the kernel, by passing through certain extraction mills, you get what is called jatropha oil. So this is the jatropha oil. This is how a jatropha tree looks like. Okay. In many parts of India, including Andhra Pradesh, Maharashtra, Gujarat, Rajasthan, jatropha is cultivated, and people extract the oil, and nowadays it is usually replaced as a biodiesel, or as an additive in small quantities mixed with vehicle fuels, and vehicle can be done. Okay, biodiesel can be used as an alternative or in blended form with normal diesel. Many oil seeds like palm kernel seeds, soya beans, jatropha seeds, canola oil, etc. can be used as biodiesel sources. These are all very interesting informations, and you imagine that the coming centuries of biofuels. Okay, our normal conventional fuels are going to be replaced with this kind of biofuels. So research is underway. You all students, as a part of the knowledge seeker, you can also be part of the research and find out new such biofuels, and we have to address our energy crisis this way, and the biofuel is the only alternative. So the main biofuels are highlighted here. Ethanol, it is obtained from plant cellulose by using yeast. And then we have biodiesel. They are obtained from either from alga, certain alga, or from oil seeds. And we have methanol. It is obtained from inedible plant matter or by roasting plant matter at high temperature. We get ethanol. Okay. So these are some important areas, biofuels and their origin, source materials. And what are the benefits of biomass energy? Just like in other cases, wind energy, solar energy, we talked about benefits. Similarly, here also, biomass, the energy obtained from biomass also having certain merits or certain advantages. The first one is it is an abundant source. Okay. It is environmental friendly and renewable. Renewable means repeatedly you can make it. That is renewable. And it's environmental friendly because it don't produce too much of pollution like other conventional fuels. Okay. And it does not add carbon dioxide to atmosphere as it absorbs the same amount of carbon. Okay. So when you burn alcohol, you may get carbon dioxide. But when you grow up or cultivate cane sugar, the same carbon dioxide is absorbed by the sugar for growth. Okay, for plant growth, carbon dioxide is required. So it all automatically gets absorbed. Okay, so this way they maintain an equilibrium in the atmosphere. Okay, one of the major advantages of biomass is that can be used to generate electricity with the same equipment or in the same power plants. Okay, for example, biogas, you can use a turbine, a gas turbine, and turbine spins the generator part and the electricity can be generated. Or in combustion, near biomass combusting, by combustion you will get enough energy that can be used to evaporate water and you get steam, high energy steam, and steam can be used to run a turbine. So that is another advantage, and you can avoid the problem of acid rain, mine spoiling, oil spill, and radioactive waste disposal, and damming of rivers. Okay, so these are all some other benefits. Okay, you don't have to go for radio or means nuclear reactors. Okay, nuclear power plants not required. Once you can replace. If you can find an alternative with the biomass source for power generation, so we can avoid installing of nuclear power stations. Okay, and biomass fuels are sustainable. Green plants from which biomass fuels are derived fix carbon dioxide as they grow. So their use do not add to the levels of atmospheric carbon. This is what we discussed earlier. And the problem of landfilling by waste can be avoided because waste will be fruitfully used. So there is no question of waste in there. Okay. So you can establish, maintain hygiene and sanitation everywhere. And alcohol-based fuels are efficient, viable, and relatively clean burning material because alcohol burning will not give you too much of pollution. Means such harmful products. Okay, just like when petrol or diesel is burned, you get a lot of radioactive products also. They are very dangerous for human body. Whereas alcohol, when it is burned, it don't produce any harmful byproducts. So these are the important parts of biomass energy conversion. And in the next module, we will be concluding the biomass module, and that will be the our next module will be focused mainly on the biogas production, different type of biogas plants and functioning and their benefits. Okay, so with that module, we will be concluding our entire paper. The entire paper on non-conventional energy sources will be finished. Okay, so you can say this is the second last module of our entire syllabus. So now here is the assignment for this module. It is like this. What is anaerobic digestion and where is it used? We have already well described. Okay, anaerobic, what is meant by anaerobic, what is anaerobic bacteria, and what sort of reaction is called anaerobic digestion. And you can include what is produced by that biogas produced and where is it used. Answer is there already. And make a brief report about all these aspects. It's a very important question as far as your university exam is concerned. So do this question sincerely and submit in due time. So with these comments, let us stop. Thank you all.